Let's take this numerical on principal strains. A mild steel plate with a hole of 50 mm dia is subjected to normal stresses sigma x is equal to 125 Newton per mm square and sigma y is equal to 45 Newton per mm square, which are at right angle to each other, and a shear stress of 30 Newton per mm square as in this figure. Find the major and minor axes of ellipse to which the round hole will deform. Take Poisson's ratio mu is equal to 0.3 and Young's modulus E is equal to 210 kilonewton per mm square for the steel plate. The hole will deform into ellipse such that the major axis of the ellipse will be in the direction of major principal strain epsilon 1 and the minor axis of the ellipse will be in the direction of minor principal strain epsilon 2. So we have to find out epsilon 1 and epsilon 2 in order to locate the hole. So we know that the principal stresses sigma 1 and sigma 2 are equal to sigma x plus sigma y by 2 plus minus root of sigma x minus sigma y by 2 whole square plus tau square. Substituting the values given, sigma x is equal to 125 and sigma y is equal to 45, and solving for sigma 1 and sigma 2, we get the values. Sigma 1 is equal to 135 Newton per mm square and sigma 2 is equal to 35 Newton per mm square. Also, the direction of sigma 1 will be such that tan 2 theta will be equal to minus 2 tau upon sigma x minus sigma y, which gives minus 2 into 30, tau is 30, sigma x is 125 and y 45. This gives value of 2 theta is equal to 36.87, so that the angle theta is 18.43 and both are negative, so they will be measured in clockwise direction. So since theta we have found is minus 18.43, the hole will deform in an ellipse such that its major principal axis is at an angle of 18.43 degrees in clockwise direction and the minor axis will be perpendicular to it. The length of the major axis will be d plus epsilon 1d and the length of the minor axis of the ellipse will be d plus epsilon 2d. So let's find out the major and minor principal strains epsilon 1 and epsilon 2. So we can write epsilon 1 will be equal to sigma 1 by E minus mu sigma 2 by E. Similarly, epsilon 2 will be equal to sigma 2 by E minus mu sigma 1 by E. So putting the values of sigma 1 and sigma 2, which we have found 135 and 35, we get epsilon 1 equals to 1 over E, that is 210 into 10 cube. Sigma 1 is 135 minus 0.3, that is for mu, into sigma 2, that is 35. So this gives a value of 0.000593. Similarly, sigma 2 will be equal to, epsilon 2 will be equal to sigma 2, that is 35 by E 210 into 10 cube minus mu, that is 0.3, into sigma 1, that is 135 by E 210 into 10 cube. This gives a value of epsilon 2, which is negative and is equals to minus 0.000026. So let us find out measure axis, which will be equal to D plus epsilon 1 D. So we get value, D is given 50 mm, 1 plus epsilon 1, that is 0.000593, which gives a value of 50.0296 mm. Similarly, minor axis will be equal to D plus epsilon 2D, that will be equal to 51 minus 0.000026, which gives value of 49.9987 mm. Let us take this another question. A flat plate of brass of 3 mm thickness is stressed by tensile forces acting along x and y directions, which are at right angle to each other. Strain gauges show that strains in x direction was 0.00110 and in y direction strain was 0.00030. E for brass is 80 kN per mm square and Poisson's ratio mu is 0.3. Find 1. The direct and shear strains at a plane that is inclined at 40 degree with x direction, and the second part is to find change in thickness of brass plate. So let us try the first part. We know that the direct strain at an plane which is inclined by theta degree is given by E theta is equal to 1 by 2 Ex plus Ey plus 1 by 2 Ex minus Ey cos of 2 theta plus 1 by 2 psi cos of 2 theta. In this case, since there is no shear strain, the psi is 0, so this term altogether cancels. Ex and Ey are epsilon x or epsilon y are the strains in x and y direction respectively. So putting values, 1 by 2 Ex is 0.00110 plus 0.00030 plus 1 by 2 00110 minus 00030 cos of Since theta is 40 degrees, we have to take 2 theta, that is 80 degrees. This gives value of direct strain E theta is equal to 0.00077. This is direct strain at a plane which is inclined by 40 degrees from the x direction. Similarly, the shear strain at an inclined plane psi theta is given such that 1 by 2 psi theta is equal to minus 1 by 2 ex minus ey sine of 2 theta, where theta is the angle of inclination, plus 1 by 2 psi cos 2 theta. Again, the shear strain is absent, so this term is 0. So we get 1 by 2 psi theta is equal to minus 1 by 2 ex, which is 0.00110 minus 0.00030 sine of 80 degrees, which gives value of 1 by 2 psi theta negative 0.00039. So psi theta will be 2 into 0.00039, which will be equal to minus 0.00078. So the shear strain psi theta is 0.00078, and which is negative. Let's take the part 2, which is to find out delta T, that is change in thickness. Change in thickness can be written as epsilon in z direction, which will be equal to sigma z by E minus mu sigma x plus sigma y over E. Since the plate is stressed in x and y direction only, so sigma z component is 0. We will have to find sigma x and sigma y, that is stresses in x and y directions. Then we will be able to find out the change in thickness. So we can write down epsilon x is equal to sigma x by E minus mu sigma y by E, and epsilon y is equal to sigma y by E minus mu sigma x by E. Solving these two equations, we will be able to get the values of sigma x and sigma y. So we can write E, which is given 80 into 10 cube. Epsilon x is 0.00110 is equal to sigma x minus 0.3 sigma y. This is equation 1, and from this we can write 80 into 10 cube, which is E, into epsilon y, which is 0.00030. That will be equal to sigma y minus 0.3 sigma x. Is second equation. Solving these two equations, we will get the values of sigma x equals to 104.6 and sigma y is equal to 55.3. Putting the values of sigma x and sigma y in this equation we get epsilon z equal to minus 0.3 104.6 plus 55.3 over 80 into 10 cube, which gives value of epsilon z equals to minus 0.000599. So delta t will be equal to epsilon z into the thickness t. So we get a value 0.000599 into 3 mm, and it is negative. So which gives change in thickness of 0.002 mm, which is contraction since it is negative.